Go, 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 go.
Extreme high. మీరు అక్కడ పీపీటీ పెట్టు ఇక్కడ చేయొచ్చు చాట్ చూడొచ్చు చూడండి వెయిట్ సార్ సమ్మన్ నో నాట్ సమ్మన్ ఓ ఎక్స్టర్న్ ఉంది See sir, it is there no? Ayush, Ayra. See sir, now this is there no? And we'll extend and we'll go simple. Now this is there no? Should do like this step. That's all power guys. Any mechanical here?
Any B2 person, please take care of the class. Too much mosquitoes.
Windows are also broken.
Yeah, next. You can see here total internal reflection. What is this total internal reflection? It's the most important topic, this total internal reflection. Apart from this total internal reflection, before that, you should know most important thing is that critical angle. What do you mean by critical angle? What do you mean by critical angle? When a light refracts with the angle 90 degrees with its normal, then the corresponding incident angle is called as critical angle. When refracted light ray refracts with the 90 degrees angle, then the corresponding incident angle is called as critical angle. This is possible. The condition is that when light ray passes from denser to rarer medium only. Denser to rarer medium only. This is possible. Okay. When light ray passes denser to rarer medium, the refracted angle makes 90 degrees with the normal. Then the corresponding incident angle is called as critical angle. This is a critical angle in this diagram. You can see here. First case, if you see vertically, it goes straight, it refracts straight. And in the second case, you are seeing light ray moving from the denser to rarer medium, but it is refracted angle is this, but it is not 90 degrees. Little more I have increased the incident angle, then light ray has refracted more. Little more I have increased a particular incident angle, then refracted angle made 90 degrees with the normal. Then the corresponding incident angle is called as critical angle. This is the most important term for understanding total internal reflection. Now, if I increase little more the critical angle, means more than the critical angle, if I increase the angle of incidence, then instead of refracting the light ray, it's reflecting back in the same medium. It is reflecting back in the same medium. Means, since it is reflecting back in the same medium, totally the light is reflecting internally only. Right here, the light totally reflecting internally. This is possible when light ray refracts more than the critical angle. Have you got it? More than the critical angle, if you are incident, it reflects back in the same medium. Okay? This phenomena we call as total internal reflection. By using this phenomena, optical fibers are made, and by using this phenomena, prisms are used as the best reflectors in the periscope. And whatever projectors you are using, in the projectors also the light, maximum amount of light. Say I can 100% also, but according to law of conservation of energy, I am not accepting that. But maximum percent of light can reflect by using this phenomena. Whereas you can see from the mirror there is a reflection. It is 80%, maybe 70%. But reflection by this process is maximum 100% we can say. Okay, that's why TIR preferred. TIR process we are using such a way that the diamond gets cut in different structure to allow the light with the more than the 24.5 degrees, because 24.5 degrees is a critical angle for the diamond with respect to air. For example, if you insert the light, if it is 25 degrees angle, the light reflects back inside the diamond, then it gives a brilliant amount of intensity. Okay, the diamond white shines because of this phenomena only. And at the same time, since you are cutting in such a way that, and that is the best application. You can some more applications are. Yeah, you can see that the relation between the critical angle and refractive index. I'll come to the application. Next we have, what are the relation between the critical angle and refractive index? This is most important concept. Always on this base, numerical questions can be asked for the important concept. From this concept, compulsory question for JE. When critical angle, I told you that critical angle is nothing but angle of incidence, which produces the 90 degrees of angle of refraction. Okay? Light ray passing from denser to rarer. According to Snell's law, light ray passing denser medium, let us say glass to air, right? Light ray passing from glass to air. So, angle of incidence I in glass, refraction in the external medium, means in the air. So, IC I can take off in the glass medium. 90 degrees we will get in the rarer medium. What is the value of sin 90? Sin 90 value 1. So sin IC by 1 I can write. Now what I am doing, simply I am making reciprocal it. When I made it reciprocal A mu G, then 1 by G mu A, which is gives us 1 by sin IC for me. This is the relation between the refractive index and critical angle. Okay? Relation between the refractive index and critical angle. Most important relation. Now, red color question. This is a note point. 2-mark question can be asked and asked also reason. Red color has a maximum value of critical angle, whereas violet color is having the minimum value of critical angle. Why it is? Because why it is so? Yeah, because refractive index is inversely proportional to the critical angle. You getting my point?
Yes, sir.
Since refractive index is inversely proportional to the critical angle, red color is having the maximum value of critical angle than the violet. Violet is having the minimum amount. Okay. Now, if you see applications of total internal reflection, what are the applications of total? Where you will use? First, mirages formation. In summer, you will drive on a roads, you will find a desert like that.
Yeah.
Okay, in the deserts, you will go long distance, there is a water. But when you go near, you will not find any water there. Just you will find the image. Then again, you will look at the forward, there is some water, there is some lake you will find. When you walk, again it will not be. So that is illusion we call illusion. That illusion happens because of the total internal reflection between the atmospheric levels. Because due to the, especially in the summer, we will find this more. Because on the surface area and the above air, there is a difference in the temperature. Since temperature difference, refractive index changes, remember. If temperature changes, refractive index of the medium changes. Why? Density changes, no? Since density changes, rarer medium to denser medium or denser to rarer medium, when light passes, it will change. Usually in TIR process, from denser medium to rarer medium, when light passes the above surface air, then it will go under the refraction, total internal reflection process. Then whatever the clouds are there above, that image will be reflected on the roads as a water. Okay, the clouds in the usually in dry air with respect to the surface of the earth. Now looming is same like mirages, which appears the palm trees on the lake or near the lakes. Next, total internally reflecting prisms. Just now I said optical fibers, which is more revolutionary in the data transfer as well as in the case of medical industry. Sparkling of diamonds. These are all the applications. They'll ask 3 mark question. List out the total internal reflection applications. You can remember these all. Okay. Next, you can see a small numerical which is refractive index as well as critical angle based. This is, we can say, concept of mirages and deserts, how it reflects from the sunlight, how the light deviates with respect to the surface. Okay, due to the deviation of the light, it appears to happen. Usually, this area of the this surface area of the air and down surface of the area temperature difference. Since temperature difference, then optical density differs. Due to that, it deviates and it reflects back to your eyes. These are the optical fibers. Here you are seeing the optical fibers. Basically, this is the wire which is most of the times the light once it is entered inside in the sense it will not come out only. Means the total light reflect in the same medium it travels. Okay, this is called optical fiber. This center part is called as core, and the out part is called as cladding. Center part core and outside is cladding. Then extra we have another coated surface is there here. Because this external surface, which why we need to coat in the sense which will not allow the light from outside to inside, inside to outside. Now you can also see how diamond sparkles here. Diamond, if you design in proper angle, then once the light enters, it goes multiple reflection inside only. Okay, so therefore, since the total amount of light reflects inside, therefore it gives more amount of light and it looks more brighter than the other stones. Critical angle for diamond 24.5 degrees. More than the 24.5 degrees, if you are incidenting, then the light goes under TIR process. Refraction through spherical surfaces is the most important topic because we are entering into the refraction through lens. You know, you studied in 10th standard this all, but once again, these are the spherical surfaces, they are the part of the spheres and they are the transparent surfaces. Okay, transparent homogeneous mediums also. That's why you can see wherever the bulging area is there, that is called as wet surface. Wherever little depth surface is called as cave surfaces. Now, here you can see this is a pole which is the center part of the lens, and this is also pole center part of the lens, and the line which is passing through the pole is called as principal axis. And you have wherever the curvature is there, towards the curvature you have center of curvature. We have written this is center C at a distance R. This center is called as center of curvature for that curvature. Here in this case, this is the center for this curvature. Okay, in lens, when you are taking double convex lens, for this lens, this side radius of curvature, for this lens, this side radius of curvature. Okay, R1 and R2, two will be there. When you join together as a biconvex lens or biconcave lens. Biconcave lens. So next, radius of curvature is the distance between the center and the pole. Apart from this, you are having the focus and focal length. Focus in the convex lens, when all the light rays passes and meets at a point or converges at a point, that is called as focus. And the distance from the focus to pole is called as focal length. Okay, the distance from the focus to pole is called as focal length. Now, there are the assumptions. What are the assumptions? Everyone must know these basics. Object is a point object lying on the principal axis. Every time we took a point, that is considered as a point object. And the incident and refracted rays makes a small angles along the principal axis. Aperture, the total surface our screen always. These are considerations while we are deriving. Now, Cartesian coordinate system. Simply, whatever we are taking, normal coordinate system, x-axis, left side negative x-axis, right side positive x-axis, upward positive y-axis, downwards negative y-axis. But at the origin, if you have the lens, with respect to that, we can write. From the lens to left side distances, negative distances. From lens to right side distances are positive distances. Simple as that. Now you can see here, after the coordinate system, refraction and convex surface. Do we need it? Don't need it. Shall I explain or not? I'm asking. Not now. Will you practice then? Tomorrow it comes in an exam. Huh? It comes in an exam tomorrow. Listen here. Next study hour 16. Next study hour. Yes. Lens maker's formula. To prove the lens maker's formula, first you should know the refraction through lens. Okay. For example, look at here. Refraction through lens. First, refraction and convex surface. Remember, I am telling in one case, this is applicable for all other cases also. This is applicable for all other cases also. Refraction and convex surface. Please do listen here. From rarer medium to denser medium, light is traveling. I am considering this is a point object. From this point object, light ray is incidenting. Okay? Since the light ray has incident, obviously it refracts. Right? Since it is refracting, this is the curvature, no? Whenever it meets at the curvature, it bends. It is bending. Because rarer to denser medium it is. This is if I draw normal, this red dotted line you are seeing, always because of normal it bends, right? So this is the angle of refraction. It is going and meeting at this point. This point I am considering here image. Okay? Now, this is a refraction takes place at the convex surface. This is a convex surface, not lens. The first part of the surface out of the lens. Okay? Now, image where it has formed? Image has formed in the denser medium only, in the glass medium only. It has not come out. Okay? Now, our considerations. Here we are taking the alpha angle with the principal axis, and since it is making with respect to normal, this is angle of incidence, this is angle of refraction, and for normal, always one important point remember, normal always meets to the center of curvature only. So it meeting at the center of curvature. So this is a gamma, and at the same time, you can see here the image where it is formed that is making an angle beta with principal axis. Why I have taken this angle? Why I took consideration? Because geometrically I need to describe the position of the object and image. Look at here, O is the object position from the point P pole. So point P to this side, that is U. I can take negative U, right? And P to I, the image distance, right side, that is V. Always object distance U, image distance V we will use, right? Now, according to the basic mathematical angles rules, I am taking here first, I equal to alpha plus gamma. I equal to alpha plus gamma. Whenever I am considering the triangles of this A, O, and CA, this complete triangle. Okay. Exterior angle equal to alternate opposite interior angles. Sum of opposite interior angles. Exterior angle equal to sum of opposite interior angles. That's why angle of incidence is equal to alpha plus gamma. Next, in the same manner, I have one more triangle, that is the triangle which you are taking A C I A. A C I A. Here exterior angle is gamma. Exterior angle equal to sum of interior angles. Who are the interior angles? Gamma equal to angle R plus beta. Clear? Now incidence angle is there, refracted angle is there for me. Whenever in the refraction process, I need two important things always. Incident angle, refracted angle. And third one is Snell's law. Snell's law. I need to connect no, because Snell's law only gives the refraction process, right? So now with respect to the angles, I am taking here tan alpha. When you are taking the right angle triangle, this AMO. Whenever I am taking AMO, tan alpha equal to alpha opposite side AM, AMA, and at the same time adjacent side is OM or MO. OM or MO. Opposite side to adjacent side. Alpha equal to MA by MO. Now, since the angles are smaller, here angles are smaller, that's why instead of taking tan, I am taking alpha. Okay? Same way, tan beta I am taking now. For taking tan beta, I should consider triangle AMI. AMI. Opposite side, adjacent side. So beta equal to MA by MI. MI is from here to here the distance. That is also I am taking small angle beta equal to MA by MI. Next, after this you can say tan gamma. What is this tan gamma? Tan gamma equal to, I need to consider with respect to this AMIC, this triangle. So tan gamma equal to MA by MC. Since angle is smaller, I am considering gamma equal to MA by MC. Now I got based on mathematics, I got the angles. Then I am entering into the physics concept. What is that? Snell's law. Okay, since angles are smaller, sin I by sin r equal to mu2 by mu1 means that is a reflected next mu2 is a mu1. I by r equal to mu2 by mu. So when you are sending that side, mu1 I equal to mu2 r. What is I? What is r? You know what this. I and r. I am substituting in the place of I and r. After substituting, any problem? After substituting in I and r, just I need to multiply. This is the I, alpha plus gamma. In a place of alpha, I should MA by M4, and in a place of gamma, I should MA by MC. Okay? And at the same time, R equal to gamma plus MA by MC, beta plus MA by MIR to substitute. That all I am putting at this area and this area. Therefore, if I rearrange this equation, mu1 by PO plus mu2 by PI, which is equal to mu2 minus mu1 by PCE. Now, the question is that what is PO? What is PO? PO is nothing but here the distance from the pole to object O, that is U. So, since negative direction is there, minus U I am writing. Okay. And at the same time, Pi, which is the distance of image in V along the positive x-axis side. So I am writing V. And the distance from the center of curvature to pole is R. Okay. So therefore, if you substitute these values in the place of PO and PI minus U, V equal to mu2 minus mu1 by R, which gives the equation for refraction at convex surface. For example, the question can come here: if it is convex surface, then refractive indices changes. Okay, and this is a concept is applicable for the real image and for virtual image. Both cases it is applicable.
Next, one second. Wait, you have that. You have this now. These are advanced. Advanced to more of us. Yeah.
This is for real image. This is for formation of real image. If it is virtual image, sign convention changes. Now, next. See, when you know the refraction at convex surface and concave surface, then lens maker formula easily you can connect. Two equations you should remember. You will automatically connect to the lens maker formula. See the same equation which we found for the till now for the real image I found. Okay. Now for the virtual image we are going to see now. This is all for real image which we have seen till now. The equation. You can see for the virtual image. You can see for the virtual image the same equation. What is the difference from the previous equation to now? Virtual image in the sense from the image to this is a virtual image which has formed here. Okay. This for this virtual image, how you are obtaining the at convex surface. In the previous case, you can see at the bottom the equation mu2 by minus u1 plus mu1 by v. And the same thing if you are seeing for the next mu1 by minus u plus mu2 by v equal to, there it is mu1 minus mu2, here it is mu2 minus mu1.